Here we have a problem on derivative. Okay, let's go with the information. Given that y equals to e to the power of 2x times 4x square plus 2x negative 3, find d square over dx square. There is a function given over here, and we have to find d square over dx square. That is, we have to find the second order derivative. That means here we have square for d numerator. So we have to find the derivative of this y twice. And both the times I have to find the derivative with respect to x. Because in denominator we have square for x. That is, when I do derivative for two times, both the times I have to do it with respect to the same variable x. Okay, first let me write the given function as it is. That is y equals to e to the power of 2x times 4x square positive x negative 3. Okay, here in the given function on the right side, we have two quantities are multiplied. In both the quantities, we find variable. So whenever two quantities are multiplied and both the quantities contain variable, and I want to find derivative of such a stuff, what I need to do is I have to use the product rule. What is product rule? Okay, now let's consider the product u times v, and assume both u and v are variables, and here u and v are multiplied, and I want to find derivative of this product uv. So for that, what I need to do is first I have to keep the first quantity u as it is, find the derivative of the second term v, that is v prime. Now I have to take positive sign. Now I have to get derivative of the first term, that is u prime, times I have to keep the second term as it is. So this is called product rule. I'm just going to use the product rule over here to get the derivative of the product over in our function. Okay, first let me find the derivative of the y on the left side with respect to x. What do I get? I'm getting dy over dx. Okay, now I'm just going to use a product rule. So I assume this is u and this is v. So now what should I do? I have to keep the u as it is, and I have to get the derivative of v. That is this 4x square plus 2x negative 3. I have to find derivative of for the expression we have in the parenthesis. Okay, for that, let me consider the first term over here. So here x square is multiplied by 4. So whenever I want to find derivative of a particular stuff where the constant is multiplied by the variable, I have to keep the constant 4 as it is. Find the derivative of this variable alone. And this x square is in the form of x to the nth power. So what is the derivative of x to the nth power? I just have to use the power rule of derivative. What is power rule? So I have to bring this exponent in front of the variable and subtract 1 from the exponent. So this is the power rule. So when I apply the power rule to get the derivative of this x square, I have to bring this exponent 2 in front of the variable. Then I'm getting 2 times x. Then I have to subtract 1 from the exponent 2. Then when I subtract 1 from the exponent 2, I'm just getting the exponent 1 for x. So whenever the exponent is 1, we don't have to mention. So simply we can write this one as x. Positive. The derivative of this x with respect to x is just 1. And the derivative of the constant 3 is 0. Okay, so far I have completed the first part, that is u times v prime. Now what should I do? I have to find the derivative of this first term. So when I find the derivative of e to the power of 2x, the same e to the power of 2x, by chain rule, I have to do further derivative for this 2x. When I do derivative for this 2x, what do I get? So usually here I find derivative for a product, where a variable is multiplied by the constant. So I have to keep the constant as it is. When I find the derivative of this variable x with respect to x, it will become what? 1. So 2 times 1 is just 2. So the derivative of the exponent 2x is just 2. So here I have used the chain rule. So the derivative of the first term e to the power of 2x is the same. And by chain rule, I got the derivative of the exponent 2x is just 2. I have to keep the second term b as it is. That is 4x square positive x negative 3. Okay, now let's simplify. So dy over dx equals to e to the power of 2x. So when I simplify the stuff over here, 4 times 2x is 8x positive 1. Positive e to the power of so I think e to the power of 2x, so we can distribute this 2 to the stuff inside the second parenthesis. When I do so, 2 times 4x square is 8x square positive 2 times x is 2x, and 2 times negative 3 is negative 6. Okay, so we get dy over dx equals to, okay, now what we have is, so here we have e to the power of 2x, here we have e to the power of 2x. So the greatest common divisor for these two quantities is e to the power of 2x. So we can factor e to the power of 2x out. So if I factor e to the power of 2x out, so what I have left in the first term? I have just 8x positive 1. So what I have left in the second term? So this expression, that is 8x square positive 2x negative 6. In case if I have negative sign, I have to take parenthesis for this one. The negative sign has to be distributed, but we don't have a negative. So it's easier for us. We can write this expression without parenthesis. Okay, so dy over dx equals to e to the power 2x. So now let's combine the like terms over here. So we can write this 8x square as it is. And when I combine this 8x and 2x, I'm getting positive 10x. When I combine this positive 1 and negative 6, I am getting negative 5. Okay, now I got the first order derivative, that is dy over dx, that's equals to e to the power 2x times 8x square plus 10x negative 5. But according to the question, we have to find the second order derivative. So that is, again, we have to find the derivative of this result with respect to x. Okay, let me do that over here. So the same thing, again, we have to use product rule because we have a product of two quantities and both the quantities contain variable. Okay, so let me write. Okay, when I find the stuff on the left side, here dy over dx, when I find derivative of this one with respect to x, I'm getting d square y. That means when I find derivative again, so I have to take square for this d in numerator. Over in denominator, I have to take square for x, that is dx square. So already I have explained you this meaning of this one. That is, we do derivative of this y for 2 times, and both the times I do derivative with respect to x. Okay, on the right side, the regular work. So first we have to keep the first term, that is u, as it is. And now I have to get the derivative of the second term v. So for that, the constant should be kept as it is. When I find the derivative of this x square, it will be 2x positive 10 times. The derivative of this x with respect to x is just 1 negative. The derivative of the constant phi is 0. Okay, now I kept the first term as it is. I got the derivative of the second term v. Now what I need to do is I have to get the derivative of the first term. So the derivative of the first term means the derivative of e to the power of 2x is, already we know that e to the power of 2x. By chain rule, if I do derivative for the exponent 2x, it will be 2. Okay, the second term, 8x square positive 10x 95 should be written as it is. So 8x square positive 10x negative 5 d square y over dx square equals to so e to the power of 2x. So when I simplify this one, I'm getting 16x positive 10 positive e to the power of 2x. I can distribute this 2 to the terms inside the parenthesis over here. Then I'm getting 16x square positive. When I distribute this 2 to 10x, it will be 20x. 2 times negative 5 is negative 10. Okay, so we have d square y over dx square equals to. So I can factor e to the power of 2x from these two terms in this expression. So when I factor e to the power of 2x, then I'm getting 16x positive 10 in the first term. And in the second term, I'm getting positive 16x square, positive 20x, negative 10. So this positive 10, negative 10 will cancel out. So then I'm getting d square y over dx square equals to e to the power of 2x. Then I can write this 16x square at first. And when I combine this 16x and 20x, I'm getting positive 36x. Okay, so d square y over dx square equals to. So I think we can factor this expression because the greatest common divisor of this 16 square and 36x is 4x. So 4x can be factored out. So if I factor 4x out, then I'm getting 4x times e to the power of 2x. So when I factor 4x out from this 16x square, so then I have just 4x in the first term and just 9 in the second term. So because if I distribute this 4x to 4x, it will be 16x square. If I distribute this 4x to 9, it will be 36x. Okay, so I got the second order derivative for the given function. So that is 4 times x times e to the power 2x times 4x positive 9.